pretty cryptic.
Okay, so telephone systems, all that we worked with, referred to as the PSTN, the Public Switch Telephone Network. The PSTN consists of local exchanges. So they are essentially an exchange office. The exchange office is where there's some sort of switching device or automated switching device that switches and routes calls that are made to it. So attached to it, attached to the local exchange, is a telephone. And here's my telephone, the little rotary telephone. The rotary telephone that's connected to it uses either pulse or TDM, tone dialing. This is how the caller tells the switch at the exchange how or what other phone they want to attach to. And the public switch telephone network actually expands well beyond the local exchange or the local office, exchange office. And we'll get into that in a minute. So the phone numbers that we dial here, we dial 608-822-2429. That information is done either through pulse, and pulse is where you have an old dial rotary telephone that you put your finger in a number, pull it down, and it goes ting, 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 ting back. That's the pulse that gets sent to the exchange office, so the switch knows that's the number you dial. A TDM, a tone, is where it actually uses a dual tone. So it uses like a grid. The tone is, and this round marker is not a good bet. Let's try black. So the tone is like in a grid. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, star, pound. And in this grid, you have tones here and tones this way. So you have so many hertz here and so many hertz here. So when you push the number 5, it sends this and this hertz tone to the exchange office, and they know what number it was that you dialed.
When you press on a home one, they have all different sounds?
Yes. Yep. Each one has a different sound that gets generated, and that's the sound that gets sent to the exchange office, so they know what digit you dialed.
So it doesn't matter if it's going to pulse.
Right. Well,
Because I remember
most new switches are only tone, but they are backwards compatible. Even back in 2002, they still had office exchanges that were using pulse. They weren't upgraded or updated to use tone.
Because I remember having a phone when I was a kid that you could,
You could switch it.
you could switch it, tone
Yep.
and pulse. And I just wondered why, now that you say that, what would be the...
Yeah, this one has it on there as well. That is, it'll T or P. You can switch it from one to the other. And most new switches, just for backwards compatibility of old phones that people have, you know, my parents still have an old rotary phone. It's mainly just for nostalgia, but it still works. They sit there, it rings, they pick up the answer. They rarely dial on it because it's a pain in the butt. You have to dial, but they still have it, and it still works. It's for backwards compatibility. They still understand. I mean, it's a pulse. A computer can understand a pulse and go, okay, that's number 4. Okay, that's number 3. You know, it's not too hard. But they did upgrade it. It's more efficient to use tone. Make sense?
Yep.
All right. All right. So that's the tone and pulse concept here. We'll erase this, and we'll get into understanding this. So this connection here is called the local loop, or also called the last mile. The connection from the office, the exchange office, to the customer is referred to as the local loop. And it only needs to consist of 2 wires. You guys have heard of a party line?
Mm-hmm. I used to have one.
Yeah, some of us used to have them. A party line is where you have, kind of like what you have in your house. If you have multiple phones, You have another phone connected here, and you have another phone connected here. But instead of in your house being rooms, imagine this is farm 1, and then a mile down the road, this is farm number 2, and another mile down the road, this is country house number 3. So what happens is the telephone company then only needs to run a wire from their office to the first farm, and then they sometimes rely on the farmer or the barbed wire fence that runs along to the next farm to hook up that wire, and then the next phone gets hooked up there and so forth. So it can be any type of copper or metal wire. You can send the signal down and have a phone conversation.
Daisy chain.
They're essentially just daisy chain, kind of like you might do in a house. Yep, definitely. So what happens is in this party line, and some of you may remember, is they would send, if the call was coming to you, they would send a certain ring tone. 1 ring is farmer number 1, 2 rings is farmer number 2, so go ring, ring, that's for farmer number 1. And ring, 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 that's farmer number 2. And sometimes Sally, farmer number 1, gets a little curious and wants to listen in the conversation that farmer number 2 is having. Right? So that's a party line.
Talking about this the other day. And she was telling there was one guy that always pick up on the phone and listen on everybody's conversation. They knew he was on there, and they'd tell him to get off, and then he'd always say, "Well, I pay the phone company, I can listen."
Yeah. Yep. So that's a local loop, and party lines are not that common anymore, but you kind of have that already existing in your house. You have that same concept. You just don't have the lines. And if you want to dial someone, you just pick up and dial, and it works. In the old exchanges, it used to be operator maintained. So the operator would use a tip and ring concept. So you might hear or see tip and ring concept being used. And that's where it's kind of like a headphone jack. You have the ring is on the back, which is kind of the ground, and then the tip is the other voltage. You have positive and negative voltage on it. So the tip and ring connection go in, and you make a connection. So the operator uses those little plugs where they plug in and use those. They actually were teapot kettle handles on the tips, and then you plug it in, and it was a cord that went around to the next one. So that's how they made the connections from farmer 1 to country store, and they make the connection, and then they can talk. Because essentially you're just creating a circuit between these two devices, and then you're sending your analog voice signal. The analog voice signal, by the way, is made by the microphone uses a little little piece of carbon, and they vibrate when you talk. Because talk like this. Talk. Put your hand there. Can you feel yourself talking?
Yeah.
The vibrations work, and that's how the microphone picks up on it. And then it creates electrical analog signals, sends it online, comes over to the speaker on the other device, and then you can hear the speaker vibrating the sounds that it needs to make with the electrical current. So pretty cool, right? Mm-hmm. Phones ring, by the way, it's another little tidbit that you should know. Phones ring by an increase in voltage. Anybody hold an electric or a telephone wire, and then all of a sudden the phone rings? We're going to do that lab in here. So what happens is you hold the line, and there's no voltage, but when you ring that extension, you'll get a little volt, a little shock. So it's kind of fun. If you like to get shocked. So anyway, so the phone rings, the little ringer in here will ring when there's an increase in voltage. So it sends an increase in voltage down to these phones, and then the little bell inside vibrates or rings. That's how it works. Or a newer technological phones, it just sends a higher voltage, and the phone goes, oh, that means I need a ring, and then it sends its ringing tone or whatever it wants to send. So that's how telephones work, and that's the basic electronics of a telephone system. Okay? So local loop, last mile, exchange office. So now let's say we want to call not just somebody within our community that's connected to the local exchange office. We want to call somebody that's in another office. Let's say there is the Madison local exchange. And the Madison local exchange connects out to more of the PSTN networks that could exist out there. And in order for us to call somebody, let's say in Madison, we need to dial whatever number that may be. So now we dial the number 1608, we want to know 344, 1234. The 344 is the prefix, that's the exchange number. The 608 is the whole area code.
Does every prefix then have its own exchange, or?
Yes, every prefix is assigned to an exchange office or multiple exchange offices, depending upon how many customers they have. So in other words, you only have 4 digits within this 344.
Right.
Right? You have dash 0000, which you can't use. So the very first one is 1. So you only have 10,000 customers there. And Madison is one of the 10,000 people. So Madison probably has multiple exchange codes that they use. So that way you can assign, depending upon the equipment inside of this exchange office, you can assign multiple exchange codes to it so they have more numbers to play with. Or there could be another sub exchange office that has an exchange assigned to it for this community. And so forth. Yes, Wes?
So for the rural area, and it's all spread out, small town, would there then more likely be some sub-exchange ones to pick up for the distance, or not at all?
No, not at all. So like for Fenimore, even though you're out in the way in the country in Fenimore, Wisconsin, they only have the 822 exchange.
Oh, okay.
Even though it's way the heck out there, bordering, Lancaster area, it's still in the Fenimore exchange, and that's where the wire runs, is to the Fenimore office. They're still using that. Just because it goes so far doesn't mean they have to have a different exchange, unless another telephone company is connecting them to their exchange. It depends upon where the wires are running. And again, this has to be a physical wire running from the exchange office all the way down to the telephone that's getting plugged in. That is the local loop, the last mile. Okay, another question.
How you were talking about the old system with the operator, how would someone like from here talk to Madison? Would they have to go to different stations and move it?
How would someone from here talk to someone in Madison? So with operators doing it, right, with the connections, it usually took several minutes to establish a call between here and Madison or any other state. So this is how it basically went then and how it also works now, but it's automated now. So in between, we'll say Mount Horeb, there is an intermediate exchange. And there's other terms for it depending upon its role. Okay, it could be a toll office, or it could be other terms that are being used there. And we have something called yeah, we love that pounding construction. Trunk lines. Trunk lines have so many, I guess, lines, or so many phone calls can be done through a trunk line at a time. So we have a trunk line from local exchange to Mount Horeb, and then Mount Horeb has another trunk line that goes between Mount Horeb and the Madison exchange. So when I dial 1-608-344, this local exchange here knows that that's a long distance call. So they go, woo, we can charge this customer so much cents per minute. 608 means, okay, I know I need to stay in the 608 area code, which is this part of Wisconsin. The 344 means that I need to route over to the Madison office. Well, how can I get to the Madison office? The most direct route to the Madison office is through the Mount Horeb Intermediate Exchange, or Toll Exchange office. So then the switch makes the decision to establish a circuit on one of these lines over here to this exchange office. This exchange office looks at its routes and decides, oh, you need to go out this trunk that we have going to Madison. Now Mount Horeb probably also has connections to Spring Green exchange office and to other locations. So the route that they take depends upon which direction you're going. Does that make sense? And then Spring Green probably has connection maybe up to Sauk City, and then Sauk City has connection back down to Madison. So that's another optional route that they could be taking, depending upon the switching that goes on here.
In case all the lines at the Mount Horeb are taken, they can go a different route.
Yeah, in case these lines are all full. Yep, and you've probably gotten that message before. Sorry, all lines are busy at this time. Please try to call again.
Yep.
That means that the local exchange office here and the intermediate exchange office, all the lines at all the trunk lines, they only paid for 100 calls at a time, or 20 calls at a time. So that means that, you know, their capacity. So the more trunk lines they have, the more money it costs, right? So they try to balance on how many calls are we ever going to get at any one particular time? How many lines do we need? Okay. So that's what they're kind of balancing out. Now we don't really run into that problem much anymore. Have you guys ever gotten that before?
Yeah.
Like recently?
IRS.
Calling the IRS, that's the IRS lines that go directly into the IRS, into their private branch exchange, not the public exchange.
During emergencies.
Right?
Emergencies.
During emergencies, you might get that. Nowadays, this is all done digitally. Your call here is analog, and then they put it into a packet and send it. Sorry, they put it into a packet and then they send it. How appropriate, a phone call, right? Yeah. they send it in a packet across a fiber optic line. They don't have 10 fiber optic lines for 10 calls. They have one fiber optic line, and they can send hundreds of calls at the same time. And it gets routed through a network, like we would typically have a network connecting computers together. That's how it's done today in most up-to-date exchange offices. But in the past, the operator would have to go, okay, hold on, let me connect you. And they knew they had a list. They just looked with their eyes and went, Madison. I get to Madison through Mount Horeb, or I can get through Basketbell. So they go, well, I know Mount Horeb's faster. I've done it before. So I'm going to call the operator in Mount Horeb. So they ring the operator in Mount Horeb, and the operator in Mount Horeb goes, oh, and they connect and go, hello. They go, hi, this is the Fenimore operator. I want to talk to somebody in Madison. Can you connect me? Sure, hold on. So then that person, I'm trying to say she, because majority of the time we're female operators, connect from here to here with a tip and ring cable. So those two lines, those two wires get connected, and then they ring the Madison office. In the Madison office, they go, hi, this is so-and-so in Fenimore. I need to make a call to this number, 1234. Because they knew that it was 344, that was the Madison exchange. So they go, just connect me to phone number 1234. So now the operator there goes, okay, and they connect here to here with the cable, and now the phone call can be made here, and this phone rings, person picks up, and they start talking. And sometimes the operator would listen in on what's going on.
Router.
They are essentially a human router. Yeah, exactly. One of the reasons why we have an automated switch today is because of an undertaker.
Ooh, yeah.
So in this little town, there were two undertakers. One of the undertakers, the funeral homes, his wife was the operator. You see where this is going?
Mm-hmm.
So this operator always knew when there was an accident or somebody died. So guess who was the first to arrive at the house or the building or wherever the person died or passed away? Yeah, her husband, because she's right away like, hey honey, quick, go over to the Johnson's house and pick up, their so-and-so died. So this other undertaker never got any business, and he got upset. So his motivation gleaned him to come up with an automated switch that didn't require a person that would listen in on the conversations. So that's the first automated switch was from an undertaker.
Wow.
Pretty cool, huh? So that's a little history.
Listening in today.
Yeah.
What's that?
We still have people listening in today.
Oh yeah, we still do have people listening in today, don't we? Right? The NSA? Isn't that awesome? Okay, so some more terminology. So this also works with private companies. So now let's say I am Southwest Tech. Southwest Tech, we make a lot of phone calls. I call a lot of people, but the majority of the people I call are within the Southwest Tech buildings or the employees here that work. So I install a PBX. I install my own private branch exchange. My own private branch exchange, then I can connect all of these phones in all my offices. Guess what this private branch exchange does? It acts just the same as the office exchanges, the exchange offices do in all these little cities. But it's more of a local. So when you are in Fenimore and you call another phone in Fenimore, do you have to dial 1608? No. You can just dial 822-1234 and it will go directly. It knows, the office exchange knows you're calling just a local phone. Same concept here. I have extension 1001, 1002, 1003, 1004. So if I'm extension 1001, all I have to do is dial 1004 and this exchange will know I'm going here, correct?
Yeah.
So now let's say I need to call this person over here in Madison because they're a customer of mine and we need to tell them that classes start at this time. So what happens is from this phone I dial 9,16083441234. This number combination goes to the PBX here at Southwest Tech. We have at Southwest Tech a trunk line as well. That trunk line, we use one of those lines. A trunk line can consist of a T1, ISDN, or POTS, or DS3, depending on your call volume. A T1 can have up to, one T1 can have up to 23 channels, or 23 lines, 23 conversations going on between this PBX and this local exchange, where we're getting this trunk line from. So we have 23 channels. ISDN, we can have 2 channels, and a POTS line, only 1 channel. A POTS line, POTS, stands for plain old telephone system, meaning that what you plug into this phone at your house is a POTS line. So if you want lots of calls, you can get 2 T1s, and then you have 46, right? Or you can say, I actually expect to receive more calls than I do send. So you can come up with better deals. So you can say, I want 23 inbound and only 4 outbound. So you can choose inbound from my perspective, inbound, outbound, depending on what type of calls you're making. So they can arrange, that they have lots of deals and ideas and things that you can do now. And they even have voice over IP options where you can get a voice over IP trunk, and it uses a special trunking protocol to communicate, which we'll learn about later, between this office and our PBX, if it's advanced enough to understand that. Wes?
Why does it matter if it's incoming and outcoming? I really don't understand when they're like, oh, it's cheaper for this one, not for that one. You're still using the signal.
Who's paying?
Money. It's a way that they can make money or make it look like you're saving money or whatnot. So, and you do end up saving money if you do. In the past, I know, when I used to work for the cable TV company, they had more inbound calls coming in, right, for their support, customer support. So, it was cheaper for them to have more inbound calls only and not outbound because of the call volume. Just like a business phone gets charged more money than a local home phone. So if you call in and say, I want to get a telephone line for my business, they're going to charge you, $80 to $100 a month for a business phone, as opposed to, I want to get a home phone for my home. They'll charge you $20, $30 a month for that. And the reasoning is you will be utilizing more of the resources with your business than you will with your home. Even though you're like, I only accept a couple calls. They don't care. That's just what they charge and how they make their money.
Can you get a home phone at a business office?
Yes, you can, but you'll be breaking their rules, and it's their services that you're paying for. Yes.
Now, could you do, like, say, a T3 connection? Is that any more channels?
Yeah.
Or is that it's still on trunk line?
Yeah, it's still trunk line, but it's T3 and DS3. Yeah, there's a lot of options. These are just some of the common ones that we're going to be talking about playing around with here. Yep. So, all right. Any other questions? Yes.
Maybe confused about it. If you make a call over IP, wouldn't you need a gateway?
Yeah, there's a lot of individual little pieces here that I'm not showing or
Oh,
talking
just
about,
now, no, okay.
but we will be getting into that later. This is just understand the basic concept of how the public switched telephone network works.
Okay.
Okay? And then how we connect to it from a PBX or private branch exchange function. All right, so moving on. Now, let's say Southwest Tech has another building they're putting up, but it's quite a ways away. And that's, let's say the apartment complex is over here. And they want to put extensions in over there for those phones so that their tenants can call out through our phone system. It's going to be cheaper than getting individual lines set up for all of them. So they put in a smaller PBX. And in between, they also have to add trunk lines, but they're called tie lines, TIE. I think it's like trunk interface exchange. It's between two private branch exchanges. They have a tie line. So this can be 2001. And then down here we can have 2002. Notice what I did with this numbering plan? This PBX has their phone number start with a 2.
So that's part of the.
Like building 100, building 200.
Which is like being a different network, exactly. So when this person dials, let's say this person right here, when they dial 2002, this PBX knows, oh, 2 sees one of these tie lines between the two PBXs. And then send the digits over here to this PBX, and this PBX will read 2002. Okay, I need to send it down here to this phone.
Okay, so that'd be like, we're kind of like how where I work, they've got, our buildings are spread out over, like we've probably got a 2 mile square radius for our entire company.
Yep.
And there's phones in every different section.
Right.
And they probably got smaller PBXs at every spot.
Yeah.
Is what you're saying.
Yeah, exactly. That's exactly what I'm saying. Yep. And you can configure this. Whoever is the person who decides to configure this, configure it any way they want to, but that's typically the way that it's done and what makes the most sense for these things to work. Let me just make sure I'm covering most of the terms that we need to. So let's say now we have another business over here that opens up, and it's just a small hair salon and spa and so forth, and they only have probably 10 phones. They have 10 phones in different rooms and offices, or like an accountant or so forth. This is referred to as a key system. And their phones, I'm going to draw a little different just because of the sake of how a key system works. So this key system then connects to the local telephone line, and we have a POTS line, POTS number 1 and POTS number 2. So we have 2 plain old telephone system phone lines, which is just like you would have at your house. You have 2 phone lines in your house. They would have the same concept here at this small business. This small business has a key system, not a PBX. And here's the difference. A PBX, in order to get an outside line or to seize a trunk line, you have to dial 9, correct? With a key system, they dial the regular phone number, but they first have to choose a line. Line 1 or line 2.
Oh yeah, we get something like that.
Yep, so when you choose line 1, that instantly seizes this connection, and line 2 seizes that connection. And all the other phones, this phone, if that line is used, will light up and say, oh, somebody's on line 1 right now. So you can visually see somebody's on line 1, I can't make a call yet until that light goes out, and then I can grab it and use it. That's what a key system is. It does the same function as a PBX, but for smaller organizations.
And that's another way for people to listen in too.
And that's another way, well, some you can block that, so you can't
Is
listen
it
in.
kind of like at a radio station where they have the, where they press a button?
Yeah, so-and-so is calling in a line, yeah, they throw that out there. Some of the other things. Ground start and loop start. These POTS lines right here can be one of two options. And this goes back to the basic electronics and basic information about creating a circuit. So I told you, right, if you make a call from here to Madison, you have to establish a circuit, correct? The wires have to actually touch, and we send electrical current over back, and that's how we hear and talk. So the option between ground start and loop start is, when you call, have you ever had this happen? Where you call somebody, you're talking to them, blah, 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 and then you go, okay, bye-bye, everything's fine. And you hang up first, and you go, okay, I need to call this next person. You pick it up, and they're still on.
Yeah.
Okay, that's loop start. Loop start uses a timeout feature. So when you put the phone on hook, let's go over that concept, on hook, off hook. This is on hook, this is off hook. When you put the phone on hook, this is the hook, by the way. When you put the phone on hook, it times out, and then we'll disconnect that circuit. This is the automated switch doing this. With ground start, what happens, anybody work in mechanics and engines, what happens when you ground an engine? The spark plugs stop firing and the engine stops, right? Okay, so a basic circuit, if you ground a circuit, it's going to break the circuit. So what happens is they ground that connection with ground start options. Our phones like this don't understand ground start. Okay, they can't do anything ground start, but PBXs and key systems do. So imagine you're working at this salon or this tax place, accountant place, and you hang up the phone. This person hangs up the phone, but this person goes, okay, I'm going to make the next phone call. And they go to grab line 1 right away. They see the light go out and grab line 1. Oh, what are you doing on? Wouldn't that be weird? Right? If you go to the CISA trunk line and there's somebody already on there. You don't want that to happen. So what you do is you configure the key system and you tell the telephone company, the central office, that you want your POTS lines to be ground start. So when this phone hangs up, a signal is sent from here to this central office to ground that circuit, kill that circuit. So that doesn't happen in a business, because you don't want that to happen. In your house, it's no big deal. You can deal with it. Okay, make sense?
Well, people just not be in such a hurry. Wait half a second. And
People are always in a hurry. I think that's about it for the basic PSTN system and how we connect to the PSTN system. Some of the different audio codecs that are used, the G711, the G729, the SSL, the signaling 7, the E164. Those are all different types of codecs, the MOS, the MOS. Those are all different codecs, meaning how these trunk lines are used between the PBX and the local exchange, and how the local exchanges talk to each other with trunk lines. So that codec is how we format the data, the voice that we're sending, and how we format it so the receiving exchange understands how to deal with it. So that's what those different codecs are. So not getting into too much detail on each specific codec, understand that there are different codecs, and that you can't have one phone system using one codec and another system using another codec. They won't talk to each other. They need to be using on that same trunk line the same codecs, so they're encoding the information the same. Okay. Any other questions? Yes.
Like I've noticed when you dial here, you can't dial like 1-800. You have to dial the 1 for the 1-800. Why is that? You have to dial the 1. What's the purpose?
1 indicates that it's a long distance call.
Okay.
Here's the deal. So Southwest Tech has trunk lines to the local exchange office here in Fenimore. But we could also have a trunk line directly to Mount Horeb for long distance. Or we could go directly to AT&T. So that means when I dial 9, the PBX goes, okay, I need to seize a trunk line here, but which one? And then you dial 822-2429, it goes, oh, that's a local call. I'm going to seize one of these local trunk lines, which costs me very little, and I'm going to use this local route. So it's a way of determining where are you routing to. And then if I dial 91608, the PBX knows, oh, that's going to be a long distance call. So I'm going to use one of these really good long distance trunk lines that we have that we're getting a really good deal at a half a second a minute, or a half a cent a minute charge, which is cheaper. Does that make sense? Why you have to do that? So the numbers you dial are there, and the reason why you have to dial them is because of how the exchange is set up. And we're going to be doing our own dial plan. You're going to be setting up a dial plan on your PBX or it's actually called a call manager because it's all IP based now. You're going to be setting it up so when you dial 911, it does something. When you dial a long distance number, it does something. You call an 800 number, it does something. You call a 900 number, it does something. So, I mean, you're going to have rules that are going to be set up that you route it certain ways. When you dial one of your peers, one of the other people in this classroom, it'll route it to their PBX and not out to the PSTN and so forth. So it'll route it certain ways. Yes?
We set up one where like you dial a number and then there's an automated message behind it.
Yes.
Like
Yep.
they could go 911 be like, you're screwed.
Yeah. Well, my router back there that I have, I'm simulating, I'm pretending to be the local exchange, the PSTN. So when you dial 911, there's a little message that plays, so you know, oh, I called 911. Because I don't want you dialing 911 to the real 911, right? So I'm pretending and allowing you to dial just right. So we're not going to be connecting to the outside lines, but you'll be connecting with a T1 card. You're going to be having 12 channels. I think 12, I remember the labs. 12 or 24 channels that you can call out on through me, through the simulated PSTN. Okay, any other questions? No? Okay.